All right, so this is going to be lesson 2 of exponentials. Okay, so today we're going to take a look at what this rational exponent means, okay, what they look like, how do we deal with them, and then also hopefully by the end of the lesson you're going to be able to take what we did from lesson 1 and apply it to what we're doing today. Okay, so that'll be the goal. So let's we'll just jump right in here. Okay, so the goal is we'll be able to work with rational exponents, okay, and then success criteria is going to be able to write them into what we call radical form and write an exponential form. Okay, so we'll be able to flip between the two as well. Okay. So let's just quickly get a little bit of math jargon out of the way here. Okay, so let's just take a look at this. Okay. A rational number is a number that can be expressed as the quotient of two integers. Okay, so that's just a fancy way of saying two numbers in a fraction, basically, right? Where the denominator is not 0. So you can't have 0 in a denominator, otherwise it just kind of like, it just doesn't work. It's a math error, right? So rational exponents are simply just fractional exponents, okay? That's what this is saying. Okay. Rational exponents are simply just fractional exponents. Okay, so you can already see, look here, like what that looks like. Okay, so in general, you're going to have like a base, and then the base is going to be raised to an exponent, whatever it is. Okay, in this case, we have 1 over n. Okay, n is always greater than 1. Okay, and then we can see, we've seen this notation before, right? N is a part of the real numbers. Right, that's what that is, and x to the m over n, just giving you the rules, okay? So we can put a little box around this, okay? These are some rules as to how this actually works, okay? So let's take a look here, okay? We'll just do some examples, and if you do enough of these examples, like the rules kind of ingrain themselves with how this actually works. Okay, so, and I'll put this in a little bit less mathy. Well, the examples will put it into less mathy kind of appearances. Okay, so let's take a look at this. Ultimately, what you're trying to do is kind of get, you want to express these as numbers, right? So you'll be able to, like, you could, in theory, type this into your calculator, right, and get a number out, but I want to see some of the work on how you actually manipulate rational exponents and turning them into radicals, okay? A radical is kind of a cool word. It's just another word for the square root, or a root, okay? It's what we call a radical, and we'll probably do a little bit more radicals after this. Okay, so let's just take a look here on how to dissect what's going on here. Okay, so this I'm able to take from here. If you look at this rule here, I can go like this, raised to the power of 3. This is another way of equally writing what's above. Now, if you were to go to your calculator and you type this in, 4 hat 1 divided by 2, if you type this in literally exactly what it is, the answer will come out to be 2. Okay, so something interesting is going on. What's the relationship between 4 and 2? Well, 2 is half of 4, but also the square root of 4 is equal to 2. Okay, so something interesting is happening here. Okay. So what you can actually do with these is whatever the number is in the denominator, and this is kind of like giving you a nice rule, okay? And like kind of practicality is this stuff up here is a little bit it's a little bit mathy. I understand that. Okay. But it's just saying the same thing. It's giving you the steps, right, of how to actually convert this thing. So it looks a little bit better with numbers, and you can see where the numbers go. So what I'm going to do is rewrite this thing. So this is actually the same thing as saying the square root of 2, right? 2 implies square root, right? And then all of this is cubed. Okay? So what you're going to do is you're going to do the inside first, and then apply the exponent onto whatever's left, okay? So with this, here we're going to go, the square root of 4 is 2, okay? And then it's cubed, and 2 cubed is 8. Okay, that's your answer. Okay? So, I just want to make sure you can keep track of or see where everything went, right? So you can see the 2, where the 2 ends up, right? So the 2, if we have our square root, and we have the hook portion, the denominator always ends up in the hook, and the numerator, the top, ends up on the outside, right? That's how this works in short form, okay? So let's just take a look at the next one. And I'll try to separate these up in blue or something. Okay, so let's take a look at this one. So what you're going to do is you're going to evaluate what's under the square root first, right? It's telling me that it is 2 to the power of 4. Okay, so 2 to the power of 4 is actually 16. And then we're not square rooting this time, we're cubed rooting, right? So that looks a little bit different, right? So for instance, if I were to go to my calculator here, okay, what you can do is you can see there is actually a cubed root. So if I can go 16, if I can type that in, and then I actually cubed root it, that should be my answer. Remember, you see what I pushed right here, okay? Okay. So let's go back to, so the cubed root of 16 is going to be 2.52. Okay, but what if I asked you to switch this back into a base with a rational exponent? How would you do that? Well, if I'm coming back down here, so I'm going to rewrite the question here. Okay, I'm going to go the cubed root of 2 to the power 4. That actually turns into 2 to the 4 over 3. So if I asked you, I could ask you either of these two things. I could ask you to do this and evaluate, give me a number. I could ask you to rewrite it with a rational exponent. Okay? That's good. Let's do the next one. So the next one we can rewrite right away. 27, okay? And then we need to take the 3 and put it inside the hook. So it's going to turn into, let me just rewrite this, give me some more room. Okay, so we're going to take the 27, take the 3, and put it in the hook for the square root, right? And this still is, the 1 is still floating there, right? So it's a cubed root of 27, which you should know as being, well, we can go type it in, but you can always ask yourself, okay, well, 3 times 3 times 3 should be 27. So the cubed root of 27 will be 3, right? Well, we'll check that. So we type in 27 and then hit cubed root 3. Okay, so that's equal to 3. Okay, so let's look at 54 to the 1/5. Well, let's just rewrite this into a radical. Okay, that's what's going to come here. So we're going to go 54. And then inside of the hook, we're going to put the 5. Okay. And then we can go back to our calculator and go, this one's a little bit different this time. You should see another button here. So if we clear this, we're going to go 54. And then instead of hitting the cubed root, I'm going to hit the y root x. So this one right here. Okay. So if I hit this, it's then going to prompt me to tell me, okay, it wants to know what is the value of y in the hook. You can hit whatever number you want. In this case, it's going to be 5. You hit equals. Okay. So we'll go back, and the answer is 2.22. Okay. This one here, you could write as 20 to the 1/3. Okay. If I asked you to write it as this is written with a rational exponent. Okay, so if I asked you to write it with a rational exponent first, then you have to write it this way. Okay, and then evaluate. If I just say evaluate, then you can just go, okay, well, I'll go to my calculator. Okay, I'll type in 20, and then I can go to the cubed root of 20, 2.71. Okay, and then I'll show you here 2.71. Okay, the other thing you can do is both of these. Okay, if you type this directly in, the answer to this should be this. Okay, so if I can go type in, with your phone calculator, it's a little bit different. What you're going to have to do is go 1 divided by 3. Okay, and so obviously 1 divided by 3, that's the exponent, 0.33333. So what you're going to have to do now is there's this other button. Okay, and you can type in 20, and then we have another button here. It's called XY. Okay, so it's just highlighted, kind of middle upper of your screen. Okay, and then again, it's going to prompt you to tell what Y is. You could type in 0.33333333333. You should get the same answer, 2.714. Okay, there you go, matches. Okay, so again, once you do enough of these are not really overly difficult, but they're important for you to see down in L. Okay, when we start combining the stuff we did from lesson 1. Okay, so again, I'm gonna say let's write this as 64 to the 1/3. We'll go back to our calculator. We can go 64 xy to the 0, 1, 2, 3. There's the 0.333s. Should be 3.999, right? Basically 4. And we can call that 4. So the cubed root of 64 should be 4. We can check that. If we went back to our calculator, we could go 64 cubed root 4. That's because 4 times 4 times 4 is 64. Okay. So let's take a look. This one here is written with a radical exponent. Why don't we, a rational exponent. We'll switch it to be a radical. So I'm going to take -8, the base, and I'm going to take the little 3 and I'm going to put it in the hook. And this turns into the cubed root of -8. You can go to your calculator. Okay. You go 8 negative cubed root, -2. Okay. Okay. So that's, if you notice, every exponent that we've done so far, with the exception of the first one. We've had kind of an exponent with 1 in it. Okay, 1/5. This was 1/3. It would have turned into, this would have been 1/3. That was 1/3. Okay, now we're starting to get into exponents that are a negative in this particular question, but also it's not a 1/3 anymore, right? So we got to be able to keep track of what's going on. So why don't so we'll switch this to radical form. Okay. And so what I'm going to do is going to go 64. I'm going to rewrite the base, and then the 3 is going to go in the hook, right? The 3 is going to go in the hook. And then I'm going to have the -4 here. Okay. So this looks a little bit messy, okay? Because you're like, oh, I don't know how to do the negative underneath the square root, right? But this would be like, this is me going at it for the very first time, right? And so now you're kind of like, what do I do now? Well, if we kind of backtrack here for a second, we apply something from the other day, from Monday, right? You remember that a negative exponent meant something, right? So what you should have done right from the beginning was put 1 over 64 to the 4/3, right? I moved it to the denominator. Now this is going to turn into 1. I can rewrite the base, okay, the 3 and the 4. So basically what you're going to do is going to do 64 to the power of 4, right? 64 to the power of xy to 4. So it's 64 times 64 times 64. And then you're going to take that number and you're going to cube root it. So your answer is 1 over, right? So you're basically doing, it's 1 over 256, but what you're basically doing is 64 times 64 times 64 cubed rooted. Okay, that should be this. There's your answer. Okay, so it's good. You can start seeing this is very similar to the same thing over and over again, right? And we're just gonna have to be able to apply it to our exponent laws. Okay, so for this one, there's all these little different variances too, right? So this one's saying, this is a nice one. We have to take our exponent and apply it to everything that's inside the brackets, right? That's what that's saying. Okay, so basically what's going to happen is you're going to go 9 to the 1/2 over 25 to the 1/2, right? To the power of. Okay, then from there, remember the 1/2 means the square root. Okay, it means square root because if I were to rewrite both of these, 9, I could put the 2 in the hook. 25. Put the 2 in a hook. So the square root of 9 is going to be 3, and the square root of 25 is going to be 5. So there's your answer, 3/5. Okay? Getting there. Yeah, and then you guys will have some questions to do. So let's take a look here. I see a negative exponent, so what does that mean? Right off the bat, I have to make it 1 over 65 to the 2/3. Okay. From there, I can put 1 over, I'm going to rewrite the base, 65. And then it's going to be, put the 3 in the hook. And the squared on the inside still. So this is basically going to be 65 squared cubed root. Okay, that's what that's saying. So I'm going to go back to my calculator. And I go 65 squared is 4,225. And then I'm going to take the cubed root of that, 16.16. Okay. So I'm going to get 1 over 16.16, which you could evaluate as a decimal. 0.06. Yeah, yeah. The problem is you can't have decimals inside of fractions. So I would actually prefer this answer. Okay. Okay. So that's us through actually using or switching back and forth between rational exponents and radicals. Okay, now you recall what do we have here? We're going to start mixing the two, right? So what you're going to have to do here is I have quotient rule, okay, where you have things of the same basis, right? Different exponents. Okay, so what you're going to do here is I'm going to go a to the 1 minus 1/2 b 2 minus 1/3. Okay, and then you're just going to go through the process of getting a fully simplified answer, but you're going to have to do through finding a common denominator in the exponents. Okay, so the first one's easy because 1 minus 1/2 is just going to be 1/2. Okay, and then so for the second one though, you're going to have to find the common denominator. So in this case, I'm going to have to multiply the 2 3/3, right? And so I'm going to get 6/6. Oh, yeah, minus, and then I'm going to have to multiply this one over here by 2/2. 2/6. So your final answer is going to be 1a to the 1/2, b 6 something over the 6. 6 minus 2 is going to be 4, which you could fully further simplify to a to the 1/2 b to the 2/3 is your final answer. I'll bring this over here. Okay. Okay. Okay, so let's finish this off, and we'll go. We can apply the exponents to each of these. Okay. So let's just quickly do this. So again, the exponent must be applied to everything inside of the brackets. Okay. And with this one, I see a negative. So we'll do two things at once here. So what we're gonna have to do is go 8 to the 2/3, x to the 2/3, divided by 27 to the 1/3, x to the 1/3. Okay, and then you can go, okay, well, this is going to turn into 8 squared cubed rooted x to the 2/3 over 27 cubed rooted of 27 x to the 1/3. Okay, and I'll deal with the numbers here first. We'll get some numbers. Okay, and I'll probably continue down on the next page here. But 8 squared is going to be 64, right? And then the cubed root of 64 we saw earlier, right? So what I've done is 8 times 8, that's 64. Cubed root of 64 is going to be 1.58. Okay. That doesn't seem right. Should be 4. That's weird. 64 cubed rooted is 4, sorry. Okay, so that's this answer here. So what I'm doing here is this. I'm squaring 8 that became 64, and then I took the cubed root of 64, okay? Cubed root of 64 is going to be 4. So I get 4x 2/3 divided by the cubed root of 27 we saw earlier as being 3, and then x to the 1/3. And so your final answer here is going to be 4/3. And then you got to do the math, or the exponent law, quotient law on that. So it's going to be x to the 2/3 minus 1/3, which is going to be 4/3 x to the 1/3. Okay. So lots going on there. Okay. Your best bet is probably just to watch the video. Okay. Which you've probably already done at this point, and then just try questions, right? And you will lock in how this actually works, okay? Where to put the exponents, each piece, the numerator, the exponent, and the denominator, where it goes, okay? And maybe I'll do up a separate video just summarizing the rules a little bit better, okay? But there's a whole bunch of examples there for you to watch through, and there's lots of work here for you too.